Okay. With our right triangles, remember we can solve right triangles using trig. Moving Sokotar. Do you need one? Right here. Okay, if we are solving for on this side and we have an angle and one side, we can use Sokotoa. If we're solving from this side and we have two sides already known, how do we put a third side without trig? Put that in there. Great. So, when we first talked about right triangles, we just quickly went over special right triangles. Now today we're actually going to go more in depth. So our first triangle here is going to be our 45, 45, 90 triangle. So you can fill in 45 and 45 right there, please. 45, 45, 90. A triangle with two congruent angles, and if I turn it, it will be congruent base angles. What type of triangle has two congruent base angles? Isosceles. Notice this side of the left is already marked length A. So what would the base length be? No, A is an isosceles. So the two lengths are congruent, so they're both of length A. Now there's a special relationship that always happens with the hypotenuse, so you can find it using the Pythagorean theorem. What's the Pythagorean theorem? Good. Where A and B are the two legs, and C is what part of the triangle? The hypotenuse. So our two legs are A and A. So I'm going to replace by A squared plus A squared, because both of the legs are length A. Equals C squared. We're going to try to find the hypotenuse. Adam, what's A squared plus A squared? We're not multiplying. We're just adding A squared plus A squared. Yep, there's two of them. 2A squared equals C squared. So we want to know the hypotenuse, which is just C. We can probably know how to find just C. Yeah? Square root, exactly. Square root cancels out the square, so we have just C. So we need to do on both sides. What's the square root of 2? No. It's irrational. Even Darn Fleet is telling me. Square root of 2. Where's the name square root of 2? What's the square root of A squared? Just A, because there are two A's makes a pair equal out front. So we have a special relationship on 45, 45, 90 triangles. If we know that our isosceles right triangle has, say, something's 5 and 5, the hypotenuse would always be 5 root 2. If this was 7 and 7, the hypotenuse would always be 7 root 2. Okay? Special triangles always have this happen. The other one is a 30, 60, 90 triangle. 30, 60, 90. I'm going to put 60 degrees down here on the bottom left, and up top, that will be our 30 degree. Okay, you can see opposite of the smallest angle, the 30 degree angle, is side length A. The hypotenuse is always of the 30, 60 triangle is always twice that. And we can go through Pythagorean theorem again, but we're not going to. But you'll find out that this missing side is A root 3. So if I knew I had a 30, 60, 90 right triangle, and opposite of my 30 degree angle was length 10, how long would the hypotenuse be? What? This? Because if you solve using the Pythagorean theorem, you do that. Because A squared plus B squared equals C squared. A is A. If you don't know B, equals, and C is 2A. So you solve for B. Yeah, you're right. Thank you. So when you subtract the A squared, you get B squared equals, something's going wrong. B equals A. I've done something wrong. Over the 2a. Ah, 2a squared. I did do something wrong. That was supposed to be a 4 in parentheses. Parentheses, magic. Oh, the 4 should go there. After squared. So this should be 4a squared. Okay. Sorry. Pause. So the c squared, yes. Oh, c squared was 2a. Oh my gosh. Sorry. Okay, this is just like pulling out thin air. Okay. There you go. C squared is 2a. Everyone follow that? That's a track squared, yes. That's what I read there in front. It's track a squared. But 2a squared is really 4a squared, because we have to square the 2, and we have to square the a, so 4a squared. If we subtract off the a squared, we get 3a squared. If you take the square root, that's how we get a root 3. Okay? Now, we use these special relationships to find the most common angles we use in trig at 0 actually, 30 degrees, 25 degrees, 60 degrees, and also 90 degrees. So, it all comes from the unit circle, which you'll be learning about more next year. The unit circle is a circle with radius 1. So if I have a circle here, with right on the origin, with the center right on the origin, the radius would be length 1. But it's anywhere on the circle because it's unit. Notice it's a singular word, it's not units, it's unit. So it's unit means 1. Okay? In standard form for an angle, we start on the x-axis and we open up. So here, this angle I've drawn so far is a 0-degree angle. If I open up to here, opening up, what's the measurement of this angle? 90 degrees. And in between, we have, I put it right in the middle, that would be what type of angle? Oh yes, it's acute, but it's right in the middle of the 0 to 90. So it's 45. Now, this 45-degree angle has a point on the circle. If I drop an altitude straight down, I have a right triangle. Which part of this right triangle has length 1? It's on the bottom. It's the hypotenuse. It's the radius part. The radius ends up being the hypotenuse right there. That has length 1. The bottom is actually less than 1. It's shorter. The bottom is length x, which we don't know yet. What's the height? Oh, it's less than 1. 1's way up here. It's just y. We don't know that. We know it's less than 1, but it's some unknown y length. And the base is some unknown x length that's less than 1. Okay? So when we find the sine of, I guess we'll start with 45 degrees because I'm talking about that one right now. Sine of 45 degrees. What was that phrase for sine, cosine, tangent? SOHCAHTOA. So when I sine, sine represents the ratio of what over what? Opposite over hypotenuse. Now for a 45-degree angle, our reference angle is down here. That angle opening up is 45 degrees. We're going to look at a special right triangle and come up with what is the sine of 45 degrees. So it's opposite over hypotenuse. You must always label a reference angle. Since we have 45 degrees, we can use either one. I'm going to use the one at the bottom. There's theta. Always labels, whenever you're using SOHCAHTOA, that's your first task is label. Which side should I label as opposite? The same? This thing, yeah. So please label opposite. Adam? Label please, opposite. Which side should I label as hypotenuse? Yep. That's our hypotenuse, a root 2. And so the adjacent side is also a because it is an isosceles triangle. So opposite over hypotenuse, so find the sine of 45 degrees. And what's the opposite? A, and hypotenuse is? So a over a root 2. A over a root 2. Notice my a's cancel out. And we're left with 1 over root 2. Now, there's three things we never, ever need in denominators of fractions. We never need fractions in the denominators. We never need i's in the denominators, and we never need square roots, or they're also called radicals. So we need to rationalize the denominator. Cindy, you know this? Does anyone know how to rationalize the denominator and push the square root up to the top? It's not very reciprocal. It's a fancy form of 1. Ryan can grab one of these papers. There you go. Okay. Okay. That would be changing to, it's very similar. Pi over 180 is a fancy form of 1. That would be changing to a radian. We need to multiply by a different fancy form of 1. That's unique to this problem. We want to push the square root of 2 up to the top. So we're going to times by square root 2 over square root 2. Because square root 2 divided by square root 2 is 1. So we're not changing the problem, right? And then multiply your numerators and your denominators. Write down what we get in the numerator, and we multiply across. But just the numerator, 1 times root 2 is square root 2. Okay, and then here we go. What's square root 2 times square root 2? Square root 4, which is just 2, because we have a pair of 2, so it pulls out. So, if I asked you what the sine of 45 degrees is, you would say root 2 over 2. No stand in the back, if you can't stay awake. Okay, now we're going to do the same thing with cosine of 45 degrees. Cosine of 45 degrees. What's the phrase for cosine? Ca. So ca to what? Adjacent over hypotenuse. So if we look at our special right triangle, we need adjacent over hypotenuse. Sadie, what's the adjacent side of the 45, 45, 90 triangle? How long is the adjacent? Adjacent is length A. What's the hypotenuse? A root 2. Does that look familiar? It is exactly the same. So you can go through the whole process again, but we know it will be exactly the same. So the cosine of 45 degrees is root 2 over 2. So put it on your chart. Make sure you're doing the middle line with the 45 degrees. Now we're going to do tangent. So toa. What is it? Soka toa. Toa. What does that stand for? Opposite over adjacent. Eric, can you please find what the opposite is and what the adjacent is? Over. So the opposite over adjacent. A over A. What is A over A? 1. So the tangent of 45 degrees is a nice pretty 1. Okay, now I do the reciprocals. Cosecant is the reciprocal of sine. What does reciprocal mean? Just flip a fraction, right? Now if I go back to this sine, 45 degrees, and flip it, then I put a square root back in the denominator. That causes me extra work. So I'm going to go back to the original. The original is right here. What do I get if I flip 1 over root 2? Root 2 over 1, which is just root 2, right? So put that in, root 2. We're going to do the same for secant 45 degrees. If I go to the ending and put, and then have the square root of the denominator. So I don't want that. I want to go back to the beginning, but we already knew it was the same, right? So it would be also square root of 2. And then lastly, cotangent is the reciprocal of which function? Tangent. Cotangent is the reciprocal of tangent. So cotangent 45, we look back at tangent and we flip it. There was 1, so we flip it and we get 1. Start you off easy. Okay, so on our chart, the 45 degrees is the easy one to memorize from sine to cotangent. Go root 2 over 2, root 2 over 2, 1, root 2, root 2, 1. Has a nice little pattern. Root 2 over 2, root 2 over 2, 1, root 2, root 2, root 1. Okay? Now can we go over a couple more things and then actually talk about what all these numbers and roots actually represent on the graph. Okay, we're going to now do 30 degrees. 30 is smaller than 45, right? It's splitting the 90 by thirds. 30 degrees. Our reference angle is right there at the origin, opening up with the x-axis. That's a 30-degree angle. So we're going to find sine, cosine, tangent. This time, we're using a triangle over there. I wonder, I don't know if I can do this, because I'm going to not be able to see both at the same time. Ooh, I know what I can do. Oh, does not let me do that on double screen. Make one a half screen. Hold on, I'm going to try something. I'm going to be able to see this triangle and not have to like scroll up and down. Okay, we're going to try this. So on the left, I'll do the root. On the right, we're going to still see the triangle. Okay. Anyway, this might be interesting. Okay, we're starting with the 30 degrees. So notice where your reference angle is. First, you have to label. Okay, Paula, which side would I label as the adjacent? There's A, 2A, and A root 3. Which one's the adjacent? There's A root 3. Adjacent. Okay? Going down, which side I label the hypotenuse? We're going to do it along this side. And so this A at the bottom should be the opposite. Okay, using that angle, your sine, cosine, and tangent of the 30-degree angle. Sine 30 degrees. So, right? So, let's be ratio for so, using our reference triangle there. This. A over 2A. Does anything cancel or simplify? Yay! What would be remaining? What? 1/2. The 2 is in the denominator. Adam, do you have this? Okay, we're going to put that in on your chart. So we have our 30 degrees. Sine, cosine, tangent, cosecant, secant, cotangent. Okay. Oh, thank you. Okay. Oh. Should I give him this homework? I don't remember. No? Okay, now we're going to do the cosine. 30 degrees. So, ka. If you could give me the ratio for ka. Good, just our hypotenuse. So on our triangle, what's the adjacent? On the triangle there, that would label what's the adjacent. Over 2A. Yep. A is canceled again, so the cosine 30 has root 3 over 2. Can we leave that as is? Yes, because the square is on the numerator, right? That's allowed. We just can't have it on the denominator. So fill in on your table, root 3 over 2. for cosine. Okay, I'm going to do tangent. TOA. Tangent 30 degrees. Okay, Davis, what would our ratio be for tangent 30 degrees? I need to get a fraction in that. TOA, opposite over adjacent. Yeah. So the 8 cancel, we have 1 over root 3. Is that one okay? No. Okay, who can tell me how to fix this issue of having square root of the denominator? Cassie? Good. Square root 3 over and the 3. Square root 3 times square root 3 is square root 9, which is just 3. Because we have a pair of 3's. We have a pair we can pull out of the square root. Okay? So this is multiplied by a fancy form of 1. It's called rationalizing the denominator. Cosecant. Cosecant, Dan, is the reciprocal of which function or which trig function? Good. So we're going to go to sine. This is 1/2. We're going to move on with it. Exactly. Cosecant. 30 degrees. We get 2 over 1 or just 2. Okay? And then secant. Secant 30 degrees is the reciprocal of which function, Maddie? They go left. So sine and cosecant go together. So secant will be the reciprocal of cosine or tangent. Cosine, yep, they just go in order. 1, 2, 3, 1, 2, 3. Okay? So we're going to go to cosine. If we put this one, we're going to have the square root on the bottom. So we might want to consider putting the next one. That sounds office. Very quickly go. The original. Okay, the original is right here. Root 3 over. Oh no, that's not. That's the same, huh? Okay. So we don't have the original. It's nice. So if we flip it, we get 2 over root 3. We can't have that, so what do we have to do? Root 3 over root 3. Okay, Brittany, we're going to multiply and rationalize it. What do we end up getting? It's not 6, because 2 is in the square root. 2 times square root 3. 2 square root 3. And root 3 times root 3 is just 3. So that one's not a mouthful. Secant 30 degrees is 2 root 3 over 3. Okay? Cotangent. That's what I'm helping you out with. I'm going to make you do the 60 degree. Cotangent is the reciprocal of which function? Cotangent is reciprocal of well, it doesn't have the but tangent. So we have tangent. So we put this one, the roots in the bottom. So we could go back to the original. 1 over root 3, if we flip that, we just get root 3. Okay, is this process making sense? Kind of. Any questions? I'm going to have you label the triangle with 60 degrees, and I'm going to have you do the 60 degrees all by yourself. So we come back to the triangle. When we change the reference angle, I don't know what that was. When we change the reference angle to the 60 degrees, our labeling changes. But only the opposite changes. Hypotenuse, always going to do hypotenuse. Yeah. So, oops, I don't think we can use this. So I'm going to change, this is weird working on a small screen. Change to my 60 degrees is now a reference angle. Okay? Connor, which side should be the opposite side? A root 3. So label that opposite. Letting have our hypotenuse, that doesn't change. Now the adjacent, Adam, almost there. You can take it out in a few minutes. Is BA. Okay, now that you have your labeling, I want you to go through the chart for the 60 degrees, starting at sine 60, all the way through cotangent 60. Make sure that the denominators are rationalized, meaning your square roots are not in the denominators, and they pushed up to the top. Now we'll talk about what all these numbers actually mean. Oh, that's true. Wow, is that thunder? Has it been raining all day? I just stay in my cave. I have no idea what's going on outside. Good one. And now just go for all in them. Yeah. You're just out there. Connor can let us know. There's got to be rain if we just heard thunder like that. I think it's supposed to rain all week. But last night, I'm pretty sure I saw like flashes of dry lightning. Like I was trying to sleep. Maybe, yeah. Make sure you rationalize the denominator, pushing the square root up to the top, using that fancy form of 1. When you get to about 6, turn to your neighbor and compare, see if you guys got the same. Make sure your reciprocal functions which you flip are the same. there? Hey, I don't get four. I'm going to give them to you and see how you did. It's not exactly the same as the 30s. Has similar. Oh crap! There's my thoughts. Wrong off. Okay. Just quickly go through the way. For the 60 degrees, sine 60 is root 3 over 2. Cosine 60 is 1/2. So yeah, this is the flip-flop of the 30 degrees, right? Tangent 60 is root 3. Cosecant is 2 root 3 over 3. Secant is 2. Cotangent is root 3 over 3. Those have all been rationalized. Those points are always in the numerator. And then explain what do all these mean. Well, we looked at we got this right triangle idea earlier. I'm going to draw a new one. It's not so messy. Okay, any angle, theta, the hypotenuse, when we talk about an altitude, the hypotenuse is 1. But the side lengths for the legs are less than 1. Because this is length x, which we know is less than 1, because our units involve the radius of 1. And we know this height, length y, is 1, or also less than 1. But this point has coordinates. So what we have been finding are the coordinates of those points. If we rotate around the circle, the coordinates for a 30 degree, a 45 degree, a 90, the 60 degree, and we can even find a 90 degree. The coordinates. What was sine again? What's the ratio? Opposite over sine theta is opposite over hypotenuse. Let's look here. If theta is in the bottom left here, what's opposite? The y. What's the hypotenuse? 1. So we have y over 1, or just, sine is the y coordinate of that point. Sine. All those signs on your tables represent the y coordinates of the points of a 30-degree angle or the 45-degree angle, the point on the circle where it intersects the circle. What's the ratio for cosine? Adjacent over hypotenuse. So looking at one reference angle right here on the bottom left, what's the adjacent side? The adjacent side is right here, x over the hypotenuse, which is 1. So x over 1 is just x. Oh, so cosine, and we'll work with this a lot more next year. This is just a brief introduction. Cosine is the x-coordinate of any angle of the unit circle over the x-coordinate. So all those cosines, this root 3 over 2, root 2 over 2, 1/2 are the x-coordinates of the points. Tangent is the ratio of sine over cosine. Next time we'll be talking about trig identities. This is one of the trig identities you're expected to pretty much for the rest of your mathematical career to have memorized. I think of it as when I do tanning, which I don't, but if I did, you put a single coat, sine, cosine, single coat of sunscreen, right? That's how I've always remembered it. When you go tanning, you put a single coat of sunscreen, like the SPF 5 sunscreen. That's just how I always remember this. I always remember the tangent is S over C, single coat, sine over cosine. That's just how I always remembered it. What was sine's ratio again? Opposite over hypotenuse. Where's my shadows in the way? Sine, that is opposite over hypotenuse. Now, maybe I'll choose an O and an H. I think that'll work better for this. O over H. What is cosine? A over H. Now remember, we talked about three things you don't need in denominator fractions. You don't need squares, i's, or a fraction. So how do you divide by a fraction, Ashley? How do you divide by a fraction? Sometimes multiply. So there's some gold card. Multiply by the reciprocal, but it's not just the reciprocal. It's flip and, copy that flip, or you could, some people here as flip and multiply. You copy the first, go to that, flip the second. Flip and multiply. And what happens to H's? They cancel out, and we get O, so that sound familiar? Toe, tangent, toe, So tangent is the ratio of sine over cosine. Now, tangent has a special property. Let's quickly do the 90s, the 90-degree angle. Remember, a 90-degree angle, the cosine and sine are coordinates. So for a 90-degree angle, the cosine is the x-coordinate. Here's my 90-degree angle on the point that reaches on the circle. What's the x-coordinate of this point? What's the x-coordinate? This is a unit circle. What's the x-coordinate? It's right above the origin. 0. What's the y-coordinate? It's a unit circle with a radius 1. It's 1. So 0, 1. So if we fill in our chart and add an extra line for 90 degrees, we can found sine is 1, cosine is 0. Tangent is always sine divided by cosine. 1 divided by 0. Oh. Tangent 90 degrees. 1 divided by 0. Thou shalt not divide by 0. Why? Not unidentified. It's undefined. Look at this line at 90 degrees. It's vertical. tangents show you the slope of that radius. Vertical slope is what type of slope? Undefined slope. A 45-degree angle. What was the tangent from 45? Tangent from 45 was 1 because it had a slope of 1. On the other one, 30 degrees has a slope of root 3 over 3. 60 degrees, slope is root 3. And then cosecant, secant, cotangent, we just flip them. If we flip 1, we get 1. If we flip 0, which is really 0 over 1, we get 1 over 0, which is undefined. Thou shalt not divide by 0. If we have undefined, which is 1 over 0, 1 over 0, we flip it, we get 0 over 1, which is just 0. So that's the 90 degrees. Sine represents the right coordinate, x represents, cosine represents the x coordinate, tangent is the slope of the radius. Okay, flipping over, I want to just review one problem on Stochastic solving using your, yeah, we're going to use this poorly copied version, unfortunately. Okay, let's just look at number 1. I'll just have to redraw it. This is a 15, and this is a 12. Okay. You can see that theta's right here. This is what your homework's like. Gabe, shush. Gabe, which side should I label as, or what should I label the 13 down here at the bottom? Based off of where the referencing is. Oh yeah, there's a hypotenuse. Leave the right angle, you're right. Hypotenuse. Okay? Kayla, which side should I label the 12? Yep. There's no need to label the other side because there's no information. So we're solving for theta, and we know the adjacent and the hypotenuse. So, which one do we use if we know adjacent and hypotenuse? Cosine. So we're going to be solving for theta. Cosine is adjacent of a hypotenuse. So we're going to go with that ratio be adjacent and hypotenuse. Excellent. So we know everything but theta. We've done this before, it's been a little while. If you remember, I said to break theta out of cosine, because it's not cosine times theta. It's cosine of theta. So we have to, then the cosines of a negative 1. Remember, that's the inverse cosine? There's a button on your calculator. Inverse cosine. So we need to do inverse cosine of the whole side. And group the 12, 13, so we put the inverse cosine always on the left. Inverse cosine, everything has its inverse. Inverse cosine cancels out cosine, leaving theta. And then you grab your calculator, and you do a second cosine, because remember you need that cosine negative 1. And you type in your calculator around to the nearest tenth, like the directions say. Okay, so that's the nearest 100. 22 I just need one digit. 22.6. Now this is theta. That represents degrees. So put a degree sign. Okay? That's what your homework looks like. Now, because so many people in A are going to bring their textbook, I have printed off the version of the textbook. I'm going to leave pass it out to this. I pull out the specific problem numbers that you're required to do. Now those are, you don't have to finish the backside. You don't have to finish the backside. Shoot. I'm going to save this. So you give me one of those? Okay, we'll just have to rewrite it, because I don't know if you guys saved it. Please write down for your homework. You don't have to do all of them. We're doing 2 through 18 even. 19 through 20, oops, I think it is 24. All. And we did 26 through 30 even. And on the back side, 42, 36, yeah. Oh, no, we're done with 40, excuse me. It was 4E2, thank you, 54 even, and both story problems, 61 and 62. There you go. We go and pass it back. Please write it down. And bring your documents back in order. You should check, read, look, and see which assignments you're missing. Everything from what I had is okay. If you have an assignment turn back that said what page is this, or please grade, you need to get that graded, or tell me what page it is and put it in the pass